Hello, I'm Pradeep Korapella,
And this is Kanhee Ko.
and this is our MATLAB project. For our project, we decided to examine the trajectory of a hurdler. We want to find the optimum angle and velocity that the hurdler should jump at.
We started off by typing in hurdle jump. It'll make our program run. And then from there we pick male or female. And when we pick, for our case, we're going to pick male. When we pick this, we have a hurdle height of 1.07, and this is in meters. And it's the official Olympic height for males. And then if we picked female, then it would be 0.99 meters, and that would be the official height for female. Then from here, we need to pick initial velocity, and we decided to pick 5 meters per second for initial velocity. Then we needed to find an angle that we jumped at, and we decided to do 20 degrees.
The program then calculates the time of the trajectory by using the position equation in the y direction. The max height of the hurdler is then calculated by using half of that time. If the max height of the hurdler is greater than the height of the hurdle, then the program would say you have cleared the hurdle. In this case, the max height of the hurdler was 0.1492, which is well below the actual height of the hurdle, so it says you have hit the hurdle. The program then calculates the horizontal displacement in the x direction. In the Olympics, the hurdles are placed 9 meters apart, so there needs to be enough space after the jump to run and be able to jump again. So since this displacement was only 1.6 meters, it says you can continue jumping. But since he already hit the hurdle in the first place, he already lost. The program then plots the x and y position of the hurdler using an array of different angles by looping through them through the equations. And then the plot shows each trajectory at the different angle. As you can see, the first 3 angles 85, 75, and 65 seem to be the optimal because it gives a height above 1. All the rest, this is at a constant velocity of 5 meters per second. All the rest of the angles are well below 1, so the hurdler will hit the hurdle and lose the race.
And then we're going to show you our script file. From our script file, when we open it, it's called hurdle jump. It is first made a menu to give the user the option of male or female. So we made a menu, a choice menu right here. And the first thing shows the name or what you need to input. Then these are the 2 values that you could input, male or female. And then there's a if-else statement to choose. If it's the first one, which is male, then it's going to have a height of 1.07 meters. And then if it's female, which is else, then it's going to have 0.99. And then next we used all of our variables that we input, such as the velocity initial and the angle, and we use that to figure out the time and the maximum height that we get.
Next, we have more if-else statements. For example, if the max height of the hurdler is greater than the height of the hurdle, then it displays you have cleared the height of the hurdle. Or else, if you didn't clear the height of the hurdle, it says you have hit the hurdle. And the same thing is here for the horizontal displacement. And then the last thing is the looping for the arrays of the angles. So here's the angle array. It goes from angle of 5 to 85 with increments of 10. This figure hold on just keeps the plots there so you can compare them. And then here's the loop. It starts with I equals 1 for the angle, and then it goes through the equation and loops through these equations until it goes to 85. And then it then plots the x and y, and then that's about it.